Hi, my name is Henry Segerman. This is the Dv30 Asteroid. So this is joint work with Saul Schleimer. So this is another puzzle. So this is very similar to the 30-cell puzzle. This is the completed 30-cell puzzle, in that there's a number of these sort of rib shapes. This time there are 6 ribs, each of which has 5 dodecahedra, which is where the 30 in Dv30 Asteroid comes from. And you're supposed to fit them together to form this asteroid-like shape. So this one actually has sort of tetrahedral symmetry, so whereas the 30-cell puzzle had some sort of 5-fold axes of symmetry here, this one has a 3-fold symmetry axis here, and another 3-fold symmetry axis here, and it's got 2-fold symmetries here. As with the 30-cell puzzle, this comes from the 120 cell, which is one of the 4-dimensional polytopes, and all of these ribs, well, all of the dodecahedra of the ribs, are cells in that in the 120 cell, and then these shapes are projected into 3-dimensional space from the 3-dimensional sphere, the unit sphere in R4, via stereographic projection. Anyway, so how did we come up with this? Where does this come from? So a long time ago I did a video on these dodecahedron chains, which is where we came up with the 30-cell puzzle from. And I promised in that video that there was a different way to fit them together. So just for reference, this is what they looked like before, and because it's sort of difficult to get them to look like this, I'm not going to do it live on camera. So somebody called Robert Tang discovered that there's a different way that they fit together. And so the core ring, as we were calling it, fits into one of the outer rings in this unusual way, which is not, we weren't expecting that this was going to be possible. And so we discovered that in fact 6 of these rings can fit inside of the 120 cell with this sort of relation between them. And so obviously we said, well, we have to make a puzzle out of this. It turns out that we had to do something slightly differently to get the pieces to be all symmetric. So rather than the 30-cell puzzle, so the 30-cell puzzle is part of the cell-centered projection of the 120 cell to R3, whereas the Dv30 Asteroid is part of the vertex-centered projection. So what does that mean? So here's a couple of different projections of the 24 cell, a different 4-dimensional polytope, just to show the difference. So this guy's the vertex-centered projection, and all that means is that at the very center of the projection, at the very center of the model, there's a vertex in there. So hopefully you can see in there, at the center of the symmetry, there's a vertex. Whereas in this one, the cell-centered projection, there's a cell, an octahedron, at the very center. So that's all that means. And so why is it Dv30? Well, D stands for dodecahedra, V stands for the vertex-centered. So, well, there would be a vertex right in the middle. There's actually just a hole in there, but if the pattern were extended inwards, there would be a vertex there. So this is the Dv30 asteroid.